Hello everyone, this is my video for simultaneous equations. I know I promised you Kickstarter and more music production today. I'm hoping to get both of these things done in the same class, but I can't really do a class on Kickstarter because there'll be nothing for you to do. So I'm just going to give you a worksheet about that and you can look into it if you want to. Okay, simultaneous equations, what are they? Well, that's what they are. They look like two equations. There's always two or three or four or five equations that are linked together. And what connects these equations is that if this x and this x are the same, this y and this y will also be the same. So we can think of it like having two algebraic equations with two variables in the ones that we have to solve. Or we can think about it like this, using GeoGebra. We can think of it exactly like this. Those are my two equations. Equation 1 produces a line going down, and equation 2 produces this line going up. And at this point, and only at this point, the two x values both 1, and the two y values are both 2. So this point right here is the solution to those equations. So when x is 1 and y is 2, we have a crossing point, and that's why that is the solution. So the two ways to think about it, either there's two lines, or in this case, a line and a curve. We don't actually have to do that until maybe 2 years later, but it's not so hard. I'll put a couple of questions on the end about that. But usually they're going to be both lines, and we know they're both lines because there's no squares or cubes in it. It's just a y and an x. Okay, so the two ways to think about it, one algebraically and the other one is graphically. Here's how to actually solve them. Now, talking about this isn't going to be so easy, but I'll try my best. Those are my two equations. It's the same two equations that we saw the graphs of, so we already know the answers anyway. Let's see how we're going to get them. I just write down the equations exactly the same again, but in the second equation, I moved the x on its own, and I moved the 3 away from the x. So the second equation has changed. It's now this. Then I look at the first equation and the second one, and I think, well, this is just x, but here I need 4x. So I've got to get 4x here too. So multiply by 4, multiply everything by 4, and now I've got an equation with 4x in it. And then I can see that 4x there. Well, what is 4x? 4x is the same as this. 4x is that. So I can take out that 4x and put in that instead. And that's what I did there. That is called substitution, where you take out one variable and replace it with some combination of the other. Then from that point on, it's just cleaning it up. So put the y's together, and we've got 9y minus 12 equals 6. Move the 12, then divide by 9. Move the 12 first, get 18, and then divide by that 9, get 2. So then we have another substitution step. Now we know y. All we've got to do is put it into this equation or this one and find out what x is. So when y is 2, 4x plus 2 equals 6. That means 4x equals 4. So x is therefore 1. Not quite game over yet, because it is possible to make a mistake on these, I guess. So we have to check in the other equation. So I think I used that equation to find my x there. So I'm going to use the second equation to see if it does really work. So 2y, well, y is 2, so 2 times 2 is 4, minus x, and x is 1. So 4 minus 1, does it equal 3, yes or no? Yes, it does. So no mistake. That's one method. And in that method, we changed one of the equations and then substituted it into that one. So that's called a substitution method. Now, I don't really care if it's elimination or substitution because, there's a bit of both going on. This time I try to do it exactly the other way. Look at the first equation, look at the second. We had a 4x in there. So if I just don't move anything, just multiply everything by 4. So this equation has a plus 4x and this one has a minus 4x. Add them up, and this x, if you can see that, this x is plus, this one's minus, and they will kill each other when we add them. So this is called the elimination method because you actually kill one of the variables by adding or subtracting the equations. So if they were both plus 4x, then you'd subtract, and then the x will go. Let's do that. Well, 4x minus 4x is nothing. And then y plus 8, y is 9y. And then 6 plus 12 is 18. So that's where we get those numbers from there. And we get the same solution that we had before because it's the same equation. And this method is graphical. On paper, this would be really frustrating and you wouldn't like it one little bit, but it's actually the easiest way to solve these equations when using the computer. Please don't use this one all the time. You have to get good at the other methods too. But you can use it to check your answers after you've found them using algebra. Okay, I'm just going to tell you how to actually do this. Well, you could type the answers in. You could, but there'll be a bit hard work because with these, I don't actually care about the answers, and I will give you no marks for the correct answer like they wouldn't on the exam. So it's all about the method. So I'm calling that equation 1 and I'm calling that one equation 2 there from there, so that when I write it out, I can see what I've done. So equation 1 times by 2. So 3x times 2, 6x, 4y times 2, 8y, and 2 times 2 is 4. And then we think to ourselves, well, that's the same as that. And when you get two equations that are precisely the same, there's no solution. Let me explain why. There's the equations again. So all you have to do is type in 3x plus 4y equals 2. And there it is, we've got our line. And then we'll type it in again for that. 6x plus 8y equals 4. Typed 89y by mistake. Okay, now we'll have a look at what we've done. Can you see that? The two lines are exactly the same. They're in the same place all the way down. So there can't be a solution, they're just the same. Now if you change that, that final number there to say an 8, these two also have no solution because they are parallel. And when they're parallel, they can't cross. And the solution is the place where they cross. So if you ever get a situation like this, where one line's just the other one moved up or down, there's also no solution as well. So how do you say that? No solution. All right, now this one, I wrote it out algebraically again. I labeled my two equations, and then I said what I'm doing. Well, I had x on its own already in equation 1. So just substitute this equation into equation 2. So that means take out that x and put this in instead. So we've got 4 plus y minus 3y equals 4. And then we just have to clean that up. Keep the 4 for now. Y minus 3y is minus 2y. Uh-oh, we got 4 on both sides. So they'll kill each other. Both of the 4s will die. And then we'll be left with y equals 0. There's nothing wrong with that. That could be a solution. Anyway, once we've got our answer for y, we then have to put it back into equation 1. Well, if x is 4 plus 0, then x must be 4. And then we check it in equation 2. So equation 2 is up there. 4 minus 0 equals 4. It's good. Little tick. And there's my solution at the end. Okay, people, I have given you not that many questions because I think we've all gone through the potato barrier. So I've given you only 1, 2, 3, 4 questions to do. Now, at the end of this, there are 2 genius questions, and it's quadratic. So it's a linear and a quadratic. I'm not going to give you any clue how to do that. I mean, no clue at all, right? Try those and see if you can get the answer. And I'll see you in class. Goodbye, everybody.